Assalamu alaikum dear students. Today we have to solve exercise 1.2 and it's question number 4 in this lesson. You have already studied about the basic ideas of matrices. What are the matrices, who give the idea of matrices, further the types of matrix, row matrix, column matrix, what are row and column of a matrix, how can we find order of a matrix. You have already cleared this concept in the last video. We have discussed these things in details, and also we have already been discussed in the last lesson, our previous lesson, transpose of a matrix, negative of a matrix, symmetric matrix, skew symmetric matrix, diagonal matrix, scalar matrix, identity matrix. And in exercise 1.2 we have solved question number 1, 2 and 3 on the book, where we have to identify different types of matrices. Now in the question number 4, find negative of matrices A, B, C, D and E. And what is the definition of negative of a matrix? Let A be a matrix, then its negative minus A is obtained by changing the signs of all the entries of A. That is, if A equal 1, minus 2, 3 and 4, then its negative minus of A will be equal to minus 1, 2, minus 3 and 4. Now in this question we are given with the matrices A, B, C, D and E, and we will find their negative. Let's see how. Simply by changing the sign in the solution for A matrix given having entries 1, 0 and minus 1. Its negative will be denoted by minus of A, and it obtained by changing the sign inside the value. 1 will be minus 1, 0 remain as it is, and minus 1 will become plus 1. This is how we find the negative of the matrix. And similarly in the next part B we have 3 minus 1, 2 and 1. 3 minus 1, 2 and 1, its negative will be represented by minus of B, and is obtained by changing the sign. 3 plus 3 become minus 3, minus 1 will become plus 1, plus 2 will become minus 2, and plus 1 will become negative 1. So its negative is obtained simply by changing the sign of the matrix. A will become minus A, 1 minus 1, 0 as it is, and minus 1 will become plus 1. So students, it's part you may say C matrix, D matrix and E matrix. You will have to find their negative in your homework. Let's move on to the question number 5. Find the transpose of each of the following matrix. We have the statement, find the transpose of each of the following matrices. And what is the transpose of a matrix? I have marked you the definition of transpose of a matrix in detail. We have discussed in the last lesson. A matrix obtained by changing the rows into columns or columns into rows of a matrix is called transpose of that matrix. Okay, we will find the transpose in that matrix. How we will find the transpose? Let's see, we have to apply one of the operation. Either we will change rows into column or column into rows. We will discuss both the cases. What happened if we change rows into column and what happened if we change columns into row. Let's see, we will discuss in question number 5 with detail. Question number 5 is, you can see the statement, find transpose of the matrix of the matrices. Students, as you have no book so far, so in the question number 4 you have did find negative of matrices. In question number 4 you have find the negative of the matrix, and in question number 5 you are going to find the transpose of this matrix. And the first matrix A is equal to 0, 1, minus 2. Taking transpose, we'll write taking transpose, we have AT, that is equal to 0, 1, minus 2. Its transpose AT is equal to, now this column changes into row. 0, 1, minus 2. It was column and it changes into row. Similarly, in B, to find the transpose, we will change row into column. In this question, we have only one row, so this is a row matrix. and in the part A we have only one column. It is column matrix. It means by taking transpose, row matrix changes into column matrix and column matrix changes into row matrix. Here we have row matrix taking transpose. Taking transpose, we have BT is equal to 5, 1, 6. Its transpose, you will write first T here. BT will remain same. And here we'll find the transpose that this row will change into column. 5, 1, and 6. Only one part I have to solve now, and remaining parts you have to solve, students, if you understand this main concept. I am going to solve the part. Next part says 1, 2, 3, first column, and the second column is 2, minus 1, 0. We have to find its transpose. C equal 1, 2, 2, minus 1, 3, 0. Taking transpose. Solution. Taking its transpose, it was solution, and it was solution. Taking transpose, transpose represented by CT is equal to 1, 2, 2, minus 1, 3, 0. T CT is equal to, this row will become column first, second row become second column, third row become third column. So this is how we find the transpose of the given matrix. Taking transpose simply changes row into column. Now what happens if we change column into row? See students, this is the column. If we change it into row, 1, 2, 3, 1, 2, 3. Similarly, 2, minus 1, 0, second column. If we change it into row, it becomes 2, minus 1, 0. So either you change rows into column or column into rows. You cannot take both a matrix obtained by changing rows into column and column into row. No, this will be wrong. A matrix obtained by changing rows into column or column into rows. It means you are taking either one of the operation. Either you are changing rows into column or column into row. So this is how you will find the transpose of the given matrix. Continuing in this way, question number 5, the last question of this exercise we have. Question number 5. Verify that if A equal 1, 2, 0, 1, then show that number 1, A transpose equal to A. B, in the second part that you will have to solve, B transpose equal B. It means taking transpose of a matrix twice result the original matrix. Students, part B you will do in homework. Here I am going to solve part 1 here. It is easy and simple. Write the matrix A here, that is 1, 2, 0, 1. Taking transpose. Taking transpose, we have AT is equal to 1, 2, 0, 1, and its transpose. AT is equal to, transpose mean either you changing rows into column or column into rows. I am going to change column into row. So this first column will become the first row and this second column will become second row. Change row into column or column into rows. I change column into row. If I change row into column, this first row 1, 2 would become first column 1, 2, not changing. So I take the AT. In the question it is given A transpose and transpose. So I will write again taking transpose. Again I am going to take its transpose, then it is equal to A transpose transpose is equal to 1 0 2 1 transpose. Now A transpose is equal to this row 1 0 would become column 1 0, and this second row become column 2 1. Now see this, is it A 1 2 0 1 1 2 0 1? So it is proved that A transpose is equal to A. Similarly, students, you will prove that B transpose equal to B. It means taking transpose twice of a matrix will result original matrix. And now continuing for let's do some working for exercise 1.3, addition and subtraction in matrices. As you know, numbers are always added and subtracted. Similarly, if we talk about matrices, the matrices are also added, subtracted, or even multiply. For exercise 1.3, you must need to understand how matrices add and subtract. For this, it is compulsory that both matrices have same order. Addition axiom is two matrices will be added if and only if they both have same order. It means their order should be same. It is not compulsory either they are rectangle, they are row matrix or column matrix. Their order should be same. It means both the matrices have same order. See the example now. We will also reading some bookwork. Let A and B be any two matrices with real numbers entries. The matrices A and B are comfortable for addition if they have the same order. They are comfortable for addition. It means addition will be possible only if they can be added. They have same order. If they have same order, we can add them. If they have different order, we can't add them. So in the example, you can see 2 3 1. First row 1 0 6. Second row. This matrix has two rows. मैंने छोटा सा ये लिखा है. And first 2 1, first column 3 0, second column 0 6, third column. Its order is 2 by 3. 2 rows and 3 column. And matrix B, you can see first row -2 3 4, second row 1 2 3. Its rows, it has two rows, and -2 1 3 2 4 3, it has three columns, so both have same order, and that's the only condition that two matrices will be added only when they have same order. Otherwise the matrices will not be added. Same rule in the subtraction, but or addition or subtraction same है. You know कि addition में हम just जिस तरह simply numbers को plus करते हैं, इसी तरह जो है हम जो matrices को plus कर देंगे उनकी respective entry के हिसाब से. We will do in the example also. So addition of and subtraction of example, I will send you the pics of these pages, and students, you need to read this for better concept of exercise 1.3. and these are the solved example you will also need to see to understand exercise 1.3 basic ideas. And if you learn these example properly, you would understand addition and subtraction of matrices. We will do the question inshallah, but before this there is another axiom, that number scalar multiplication. If there is a number, if given any matrix, and if our number wants to multiply with a matrix, then that number will multiply with all its entries, with all its member. Let's see an example for this. Multiplication of a matrix by real number. Multiplication of a matrix by a real number. Suppose I have a matrix. Example, if I have a matrix A having order 1 3 8 0, and if a number 8 wants to multiply, and if we multiply 8 with matrix A, it will multiply in the left hand side, and in the right hand side 1 3 8 0, it will multiply with all the entries inside. 8 multiplied by 1 8, 8 multiplied by 3, 8 multiplied by 8, and 8 multiplied by 0. This axiom is called multiplication of a matrix by a real number, by a number. 8 1s are 8, 8 8s are 64, 8 3s are 24, 8 into 0 is equal to 0. So this is the result you obtain, that is called A matrix. And which wants to multiply with the matrix, it would multiply with the whole matrix, with the whole elements of that matrix. Continuing in this way, there are some basics law. Students, you need to mark them. What is commutative law? If we add A plus B equal B plus A, such kind of law in which a matrix appear first and B after, and B first and A after. Any law in which two numbers are added, first number plus second number, and second is equal second number plus first number, you only need to mark this commutative law. I will explain you this in the real number in chapter 2 as well. In chapter next classes for FSC, it is helpful laws. Here just you need to understand what is commutative law. Commutative law of two numbers, it exists in numbers, in real numbers, and in matrices it is A plus B. Two matrices sum is equal to A plus B equal B plus A. It means two numbers को हम पहले A को लिखें या बाद में B को लिखें, B को पहले लिखें बाद में लिखें, ये दोनों इक्वल ही होते हैं. This law is called commutative law. Students, you need to understand this. Associative law, similarly, students mark this. Okay, if we add first two number in the bracket, we'll add two matrices A plus B, and then add it into the third matrix is equal. If we add last two matrices and the result is added into the first matrix, then this law always both answer of the both the side equal. And this axiom is called associative law of matrices. It also exists in numbers, in real numbers. Here I want to explain you just matrices and determinants, so just you need to mark it. Okay, and additive identity of a matrix, you need to mark this A plus B equal B plus A. Additive identity in a matrix is that one, that B is a null matrix. Null matrix is always additive identity. Students, you will not understand this properly. I will explain you inshallah when we have classes, one-to-one classes, and face-to-face I will face you. Here you just need to mark A plus B equal A and B plus A, and also inverse law. Student, mark this. And now we're going to solve exercise 1.3, and its question first will be solved on the book. See this question number first. Which of the following matrices are comfortable for addition? Which of the following matrices? Here I was given with A, B, C, D, E, F. A to F matrices are given to me, and what I have to do, I'll have to find the so I have to check that which of the two matrices are comfortable for addition. As you have already studied and I explained you, two matrices are comfortable for addition only if they have same order. Now we will find the matrices having same order and add them. Let's see. A matrix is 2 1 minus 1 3, and again another matrix minus 1 0 1 2. This matrix A has 2 1 minus 1 3. Its order is 2 by 2. Its order is 2 by 2. Matrix A has number of rows, first row, second row, number of column, first column, second column. A has 2 rows and 2 column. Similarly, matrix E has 2 rows and 2 column. Those two matrices are said to be comfortable for addition if they have same order. So A and E are comfortable for addition. Now see another matrix B 3 1 and D 2 plus 1 3 3 3. So B 3 1, D 3 1, 2 rows 1 column, 2 rows 1 column. B and D are comfortable for addition. And at the end C and F, C has first row, second row, third row, first column, second column, and F first row, second row, third row, first column, second column. Its order is 3 by 2. C and F also has order 3 by 2. So C and F are comfortable for addition. Students, you just need to only tell that the matrices having same order, they are comfortable for addition. That's it. So in all 6 matrices, you will check those matrices having same order and write that they are the comfortable for addition. How simple is that? And this is not a difficult task for you, and it is simple. You not need to worry about this. Just find and check out the order of the matrix. You would understand they are comfortable for addition or not. And exercise 1.3 we have just started now, and it's question number 2. You have to solve on the book. I will explain you a statement, but before this I'll write the statement. Question number 2. Find additive inverse. Find additive inverse of the following matrices. In the question number 2, A, B, C, D, E, F are matrices given to me. Additive inverse is a matrix. You may say it's a negative of another number. If I talk about real numbers, in real numbers, if I have 5, then its additive inverse is such a number. If I add this number in it, I would get the answer 0. तो 5 को 0 किससे हम कर सकते हैं? By only adding -5. 5 plus minus 5 equal 0. It means 5 का एडिटिव इन्वर्स हुआ -5, 7 का एडिटिव इन्वर्स हुआ -7, 8 का एडिटिव इन्वर्स हुआ -8. एडिटिव इन्वर्स ऑफ अ नंबर इज सच अ नंबर दैट गिव इट दैट इट मेक इट 0. कि 5 में क्या माइनस करेंगे प्लस करेंगे, 0 आंसर है -5. तो 5 का एडिटिव इन्वर्स हुआ -5. सिमिलरली 7 में क्या ऐसा हम ऐड या सब्ट्रैक्ट करें कि आंसर हम आया -0 आए, it is -7. But in matrices, the additive inverse of a matrix is a matrix that will make it 0. Let's see a generalized example. Here I will solve first. Example, if A is a matrix having 2, 3, 7 and -4. Now, how A could become 0? If I add -2 here, if I add -3 here, if I add -7 here, and if I add +4 here. So it means if I add, it's negative. -2, -3, -7 and +4. If I add negative of that matrix into it, I would get its additive inverse. So in the question number 2, first part, A is equal to 2, 4, -2 and 1. You will just student mention additive inverse is equal to -2, -4, +2 and -1. Simple is that. Additive inverse of a matrix is the negative of that matrix. It means you will change the sign inside the matrix and call it additive inverse. Another case, in the D part, matrix D, 1, 0, -3, -2, 2 and 1. Its additive inverse will be its negative. 1 can become 0 from -1, 0 remain as it is. -3 will become 0 with +3, -2 will become 0 with +2, +2 becomes 0 with -2, and +1 becomes 0 with -1. So in additive inverse, you just need to change the sign of that matrix and call it as additive inverse. It is simple. Now let's move on to the question number 3. In question number 3, we have to add the matrices. Question number 3, if A is equal -1, 2, question number 3, it is given that A is equal -1, 2, 2 and 1. Matrix B is given. Matrix B is 1, -1. Matrix C is equal to 1, -1, 2. And matrix D is equal 1, 2, 3, -1, 0, 2. Students, it has a 9th part and they are very simple. The first part is find the value of A plus 1, 1, 1, 1. We have to find the value of A plus and the matrix 1, 1, 1, 1. You will simply need to do nothing and put the value of A. What is A? A equal -1, 2, 2, 1. So instead of A, we will substitute its value. That is -1, 2, 2 and 1, and add in the next matrix 1, 1, 1, 1. Okay, it is simple. And addition, as you know, -1 plus 1, 2 plus 1, 2 plus 1, 1 plus 1. So this is how you find the value of the given question. Simply there will be a matrix and a matrix notation will be given. Matrix notations की value A, B, C, D आपको given है. Just put that value and add them. -1 plus 1 is equal to 0, 2 plus 1 equal to 3, 1 plus 1 is 2 and 2 plus 1 is 3. So you have find its value. So students, in this question I will solve question. First I have solved for you 6 and 6, 4 and 8. I have to solve next, and rest of the part will be given to you as a homework. So I have just solved its first part. Now I am looking forward to solve the fourth part. And fourth part, it is given find the value of D plus 0, 1, 0, 2, 0, 1. Simply the value of D is notation given, put the value of D. What is D? 1, 2, 3, -1, 0, 2. Put its value. Instead of D, I will write now its value, the matrix, -1, 2, 3, 1, 2, 3. It is given in the question, -1, 0, 2. Instead of D, I write its matrix. So I add them, 0, 1, 0, 2, 0, 1. Add them, and addition rule is first row first element and first row first element, 1 plus 0. First row second element, first row second element, 2 plus 1. First row third element, first row third element, 3 plus 0. Second row first element, second row second element, -1 plus 2. Second row second element, second row second element, second row third element, and second row third element. It is simple. Now add them. 1 plus 0 is 1, 2 minus 1 is 1, 2 plus 1 is 3, 0 plus 0 is 0, 3 plus 0 is 3, and 2 plus 1 is 3. They are the simple one. Now we'll have seventh part. I am going to solve 7 and 9. So it's 7th part. We have to find the value of -2 into C. Student, this -2 is multiplying with C matrix, and how we will multiply it, I have explained already you about the multiplication of a matrix by a real number. Multiplication of a matrix by a real number. A matrix, if given, 8 was multiplying with that matrix, and here I have -2 multiplying with this matrix. It is simple. -2 will come on its position, and C matrix is given 1 minus 1 2. C matrix is given in the question 1 minus 1 2. So instead of C, I'll write 1 minus 1 2 here. Now -2 is will multiply inside it. -2 multiply by 1, -2 multiply by -1, -2 multiplied by 2. This is equal to -2 minus minus plus, 2 ones are 2, and minus plus minus 2 twos are 4 with the minus sign. Students, addition and subtraction of the matrix, if you face any problem, I will explain you with detail in next question number 4 and 5. You may also use calculator and write on the calculator -2 multiplied by 1. You will see answer -2. -2 multiplied by -1 on the calculator as minus minus plus, 2 ones are 2. Minus plus is -2 twos are 4. Addition in matrices and multiplication of matrices while having negative number, it has some differences, and it is very much will be explained in the next videos to you, where we have lots of sum having addition and subtraction of negative numbers, and further we will also discuss their multiplication. And last part I am going to solve for you to is 9th part. Inshallah, we will solve question number 4 in the next lesson, and this is the last part for you, in which you have to find the value of 3c. It is simple. 3, value of c is given to you. 1 minus 1, 2. 1 minus 1 and 2. Now multiply 3 with this. 3 into 1, 3 into minus 1, 3 into 2. It is equal 3 1s are 3, plus minus minus, 3 1s are 3, 3 2s are 6. That's it. It is the value of 3c. So students, they are the simple operations in matrices of addition and subtraction and multiplication with a real number. Inshallah, we will discuss further on addition and subtraction in the next lesson. Till then, thank you so much. Allah Hafiz. God bless you, students.